So in this video, focusing on algebra, we'll be looking at how to solve one-step equations. So typically in maths you are often given a calculation involving addition, subtraction, multiplying and or dividing, and to use BIDMAS or BODMAS, it's sometimes known as, to find the calculation. Now when you are asked to solve an equation, one of the numbers in the calculation is missing and you need to find what that number is. Now in the early days a box was used to represent a missing number, however in algebra this box is replaced by a letter. Now this can be absolutely any letter, it could be any letter in the alphabet, but typically more often than not, and particularly at a higher level, you tend to find that that missing number is x, a bit like x marks the spot, x is a mystery, etc. So hopefully if you look at the example you can say complete the calculation. Now at primary school you may have come across these types of questions when you've finally mastered additional subtraction. It's kind of introducing the concept of working backwards, which is basically what solving equations is all about. So when you only have one mathematical symbol in a calculation, this is what is meant by a one-step equation. This is because there is only one thing you need to do to find out what the final answer or to know the value of the missing number. Now depending on how good you are with adding, subtracting, multiplying, dividing, you may be able to simply spot the answer just by looking at it and solve it mentally. However, it is important that you do understand the process of solving an equation, as it will make solving 2, 3, 4, etc. step equations much easier to solve. Now as mentioned, when finding part of the question and being given the answer, this is like the reverse of what is usually asked to you in maths. And it is this reverse process that we need to use when solving equations. Now the important thing when you have written down what you think you know what the value of the letter is going to be or the missing number is going to be, so it's really important that you check your answer to see if it actually works. So let's have a look at some examples. So here we've got a selection of 9 different questions, and just by starting off let's just kind of reevaluate what these questions are. So this question for number 1 is exactly the same as this. So if you wanted to, you could replace the letter with the box, but again you don't really want to be wasting your time on that. So you're thinking what number plus 4 gives you 7, and again most of you will simply go on to working out that the mystery number is going to be 3. So here we've got x equals 3. Now in terms of the concept of what you're actually wanting to do is we want to try and get x by itself, and at the moment x has got plus 4 on the same side. So you want to think, well, how do I get rid of that? Well, if you see the equal sign is like the opposite sign, one way of getting rid of positive 4 is to do the opposite, which is to take away 4. Now if I do 7 take away 4, I end up with the answer of x equals 3, and it's this opposite kind of method that you want to look at and focus on. So here with question 2, we've got minus 12. I want to get x by itself. What's on the same side as x? Minus 12. What's the opposite of subtracting 12? Well, that's going to be to plus 12. So then I've got x by itself, and I've got 6 plus 12, which is 18. Then here, now when you've got a letter on the sort of right hand side of the equal sign, then this is exactly the same as y plus 4 equals 10. Now you can change things the other way around if it helps you, but just remember that you're taking the sign of whatever you're swapping around the same as well. So here my 4 is positive, so the 4 is positive. Here the y is positive, so here the y is positive. So that's absolutely fine. So I want to try and get rid of this 4, and the 4 is being added to y, so the opposite would be to take away 4. So then I've got y left on this side, and I've got 10 take away minus 4, which is 6. Here, so this time we've got minus 3 that I want to get rid of. So the opposite of taking away 3 is to plus 3. So here I've got t equals 8. And in question 5, I want to get rid of plus 12. So the opposite of plusing 12 is to take away 12. And so I've got h equals 8 take away 12, which, now with this you need to be careful with negative numbers, because I'm starting off with a smaller number and I'm taking away a bigger number. That means that the answer therefore is going to be minus 4. And again here, even though they're flipped, it doesn't really make a difference. I want to get rid of this 3 and it's being added, so I need to take away 3. So I've got f equals 74 take away 3, which is 71. And then with regards to question 7, Again, I want to get rid of 5, and the 5 is being added to W, so the opposite is to take away 5. So I've got W equals minus 2 minus 5 is minus 7. And then question 8, again I want to get rid of this minus 6, and the minus 6 is being added to 12. Now here, what we want to do is minus 6. Now depending on how comfortable you are with negative numbers, two minuses make a plus, so then this then becomes, let's just get rid of that. So here we get these two minuses become a plus 6. So then what we've got is G equals 10 plus 6, which is 16. And then here we've got minus 3, and it's being added, so I need to take away minus 3, and two minuses make a plus. So here I've got minus 15 plus 3, which gives me minus 12. Now if I just go back with regards to any of these questions when we talk about checking the answer. So for example, if I take question 6, here I can see that the missing number I've worked out as being 71. So then if I then check to see if this is correct, we've got, let's get a pen that actually works, there we go. We've got set 3 plus 71, and the question is, does that equal 74? Yes it does, so 71, not 3, don't know why I've done that. So here we've got 71 is our final answer. Now the one thing that you do need to be wary of, and this tends to appear on more high level questions, is when you've got negative letters. Now make sure that there is a difference between negative numbers at the front, like we had with regards to, and if I just scroll back up, so for example if you look at question 8, we've got a negative number at the start, that's not a negative letter. In question 9 we've got a negative number at the start, but that's not a negative letter. So in these particular examples, here what we've got is negative letters. Now when you have got negative letters, it's slightly different, and we can't simply swap the two things round. Now as I said, this tends to be more higher level. Now when you've got a negative letter, what you want to do is make it positive first. So what we're going to do is we're going to add x. So here I've got 3 equals 10 plus x, and by doing that what we've got is we've now got a positive letter. Now this is exactly the same as x plus 10 equals 3, and if you look back at what we did earlier, I want to try and get positive x by itself, so I need to get rid of plus 10. So the opposite of that is to take away 10. So I've got x left on this side, and I've got 3 take away 10, which is minus 7. So again here, I take the q over to the other side to make it positive. So I've got 10 equals 12 plus q. And again, if I just keep it as this side, I want to get rid of 12, and 12 is being added. So the opposite of adding 12 is to take away 12. So here I've got 10 take away 12, which is minus 2, equals q, and which is exactly the same as q equals minus 2, and there is the answer. And then finally for question 3, again I've got a negative letter, so I'm going to take that to the other side to make it positive. So what I've got is I've got 2 equals minus 8 plus y. As I said, most students tend to not like this in this way. They much prefer this to be on the left hand side. So if we just flip those two things around, which I can perfectly do, so I've got minus 8 plus y equals 2. And again, I want to get rid of this minus 8 because I want to get positive y by itself. So what's the opposite of adding minus 8? Would be to plus minus 8. To take away minus 8 rather. Again, mistakes can easily be done. And again, the reason why we're taking away is because I want to reverse this sign here. So minus 8, and two minuses make a plus. So here I've got y equals 2 plus 8, which is 10. Now again, if I'm not too sure about the answer, what I can do here is I can check. Okay, so I've got y equals 10. So if I just replace y with 10, does that equal 2? Well, yes it does. So therefore 10 is the correct answer. And there we go. So let's move on to multiplying. Now one of the rules of algebra is that we don't use the multiplication symbol, the x. Instead, when numbers are being multiplied by a letter or letters being multiplied by other letters, we simply merge the two things together. And when we do that, we need to make sure that we're making that numbers, if we have got any numbers that are at the front, and any letters that are being multiplied together all tend to be written in alphabetical order. So for example, if we were wanting to work out 3 times t, then we would write the answer as 3t. If I was doing 5 times g, that would equal 5g. T times c, that would be ct. And again, because we're making sure we've got alphabetical order. Now, if you're doing a combination of lots of letters and numbers, so for example, 4 times f times y, then that would be just simply written as 4fy. And if we were doing 4 times b times a, then again, we write the numbers at the front and we tend to write the letters in alphabetical order, so it'll be 4ab. Now, when solving equations involving multiplying, we must spot that when there is no multiplication, a mathematical symbol between a number and or letters, that they are being multiplied together. So for example, if you can't see any sort of mathematical symbol, whether it be a plus, a minus, or a line, or a divide, then just assume that they are being multiplied together. Obviously this does not apply to numbers, so for example, if you had 3, 2, that does not mean, does not mean 3 times 2, that would simply mean just 32. So it's only when you're multiplying letters and numbers or letters with letters, if you can't see any mathematical symbol in between them, then you can just assume that they are being multiplied. So let's have a look at some examples. And so when we're multiplying, so here we've got 3 times m. Now this question is exactly the same as 3 times, and I put a little box around it, equals 18. So again, you can either answer this mentally, so you think to yourself, okay, how many 3's go into 18, which is generally what you're doing. But like I said, what you want to try and do is focus on this method of doing the reverse. So I can see here that 3 is being multiplied by m, and I want to try and get m by itself. So the opposite of multiplying by 3 is to divide by 3. So I've got m equals, and it'll be 18 divided by 3, which is 6. Here I'm being multiplying by 5, so the opposite is to divide by 5. So I've got x by itself, and 60 divided by 5 is 12. Here I'm multiplying by 7, so the opposite is to divide by 7. So I've got y equals 28 divided by 7, which is 4. Here I'm multiplying by 8, so the opposite is to divide by 8. So here I've got m equals 48 divided by 8, which is 6. And then 4 times, I'm multiplying by 4, so the opposite would be to divide by 4. So I've got r equals, and again, how many 4's go into 16? That would be 4. And I've got odd number of negative numbers, so the answer then is -4. Now, what is important, again, this kind of leads into more sort of high level work, is if you get something where the answer isn't a whole number, do your best, particularly with algebra, leave it as a fraction. So for example, if you had 4t equals 7, now to get rid of the 4 we need to do the opposite. Now the 4 is basically, that's 4 times t, so the opposite of timesing by 4 is to divide by 4. However, 4 doesn't go into 7 nicely, so what I'm going to do instead is I just leave it as a fraction, and there you go. And this is how some of these questions tend to appear on non-calculated papers or questions, because no one's really expecting you to be able to work out what the decimal answer is going to be. So if there is anything that you're not too sure about or don't quite know the answer, it doesn't necessarily mean you've gone wrong. It just may mean that they're trying to focus on getting you to write your answer as a fraction. Now if you have got an improper fraction, you could write it as a mixed number, so this would be 1 and 3/4, but again, it's not really essential unless it tells you in the question. So I would say leaving your answer as an improper fraction in its simplified form would be more than fine. So let's have a look at the last operator that we've not looked at, which is dividing. So another rule of algebra is that we don't use the division symbol, and instead what we do is we write the division as a fraction. So for example, if I wanted to do t divided by 3, I would write that as t over 3. If I want to do m divided by 5, I'd write m over 5. If I was to do x over y, so 2 letters being divided, then the first thing goes on top, the second thing goes on the bottom, and that's the best way to do it. So here with question 4, 3 is going to go on top and x is going to go at the bottom, and that's absolutely fine. So when you do see a fraction, basically means divide. So then when we're going on to solving these things, and again we want to think to ourselves, we want to try and get x by itself. So here on the same side as x is divided by 6, so the opposite would be to times by 6. So x equals 5 times 6, which is 30. Here I'm going to get rid of the 3, and the 3 is being divided by, so I'm going to times by 3. So here I've got x equals 45. Now what you generally find is that when people are taking things to the other side, you can kind of cancel that out, because I've taken that 2 over to the right hand side. So I've got t equals, in this case, 23 times 2, which is 46. And here, dealing with negative numbers, I'm going to take that over to the other side by multiplying by minus 4. So here I've got x equals, and again let's get rid of that, so 3 times 4 is 12. I've got odd number of negative numbers, so then the answer then is minus 12. So hopefully we've just gone through the simple basics of solving equations, and like I said, this whole concept of reversing and trying to get the positive letter by itself is a really good sort of aim to have when dealing with these equations. Now again, you might get to the answer straight away. These questions will only be worth 1 mark, so as long as you're writing the letter equals and the correct number, you'll get 4 marks. But this whole concept of reversing and taking things to the other side by doing the opposite will definitely help you when it comes to more complicated and definitely more common solving equations questions. Now there are going to be some questions with some answers in the description below as a worksheet, so feel free to practice what you've just learnt.